Okay, let's unpack this. Welcome to the deep dive.
Great to be here.
Today we're diving into, well, the Pacific pendulum. What's happening with global climate? Specifically, ENSO, the El Niño Southern Oscillation.
Yeah, there's a lot going on right now.
Absolutely. So our mission is to cut through some of the noise, pull out the key insights from the latest NOAA reports, climate models, research papers you've been looking at.
Right.
We'll hit the current La Niña watch for fall and winter 2025-2026 here in the Northern Hemisphere.
Mm-hmm.
And then maybe the bigger story, this surprising long-range forecast pointing towards a, well, potentially significant El Niño kicking in later in 2026.
It's definitely something we need to watch.
And this isn't just, abstract weather stuff. It's about the big picture climate drivers that, well, they impact you directly.
Exactly. So right now, as of August 2025, NOAA's got this La Niña watch out.
Okay, so what's driving that? What are the signals?
Well, the main oceanic one, the Niño 3.4 region.
That's the key spot in the Central Pacific, right?
That's the one. It's our main temperature gauge for ENSO. And it's definitely showing a cooling trend. It's at minus 0.3 degrees Celsius right now.
So creeping down toward that La Niña threshold.
Getting really close. The threshold's minus 0.5 C, so yeah. But
There's always a but, isn't there?
there often is with ENSO. What's fascinating here is this kind of internal conflict in the ocean.
The tug of war?
Sort of. While the Central Pacific cools the bit further east, the Niño 1+2 region off Peru and Ecuador, that's still quite warm. Anomalously warm, actually, at plus 0.8 C.
Huh. So like a warm patch holding things back.
Yeah, think of it like a thermodynamic break, almost.
Right.
It's stopping a really strong basin-wide cool down. For now, anyway.
Okay, but what about underneath the surface?
Well, that is crucial. Since mid-July, we've seen these negative subsurface temperature anomalies, basically. Pools of colder than average water reestablish and strengthen in the East Central Pacific.
So there's a reservoir of cold water building up down deep.
Exactly. Ready to potentially influence things more strongly later.
Okay, that's the ocean side. Pretty complex. How's the atmosphere reacting to all of this push and pull?
The atmosphere is definitely responding. We're seeing those crucial low-level easterly trade winds strengthening over the east central and eastern tropical Pacific.
And those winds push the warm water west, pulling the cold water up.
Precisely. It's the classic mechanism. And satellite data, it's showing the quintessential atmospheric signature of La Niña starting to set up.
Meaning?
Meaning less cloudiness and rain, suppressed convection near the dateline in the Central Pacific, and then the opposite, enhanced convection, more storminess over Indonesia and the maritime continent.
So putting these ocean and atmosphere clues together, what's the forecast for the coming winter, 2025-2026? Are we locked into La Niña?
Well, the consensus forecast is actually for a pretty weak and likely brief La Niña event, if it even fully forms.
Oh, really? So not a slam dunk?
Not at all. The probabilities for La Niña, they peak around 41% for the October-December period, but ENSO neutral conditions, they're still almost equally likely at 49%.
Wow, that's basically a coin toss. Borderline.
It really is borderline. If it does form, the peak intensity is forecast to be pretty weak, maybe minus 0.5 to minus 0.8 Celsius, and it's expected to fade back to neutral by spring 2026.
Okay, here's where it gets really interesting for you listening, especially in North America. What does a weak borderline La Niña mean for winter weather?
Well, normally, even a weak La Niña tilts the odds towards warmer and drier conditions in the southern U.S. and cooler, wetter up in the Pacific Northwest.
The typical pattern.
A typical pattern. But there's this huge wild card this year.
Which is?
The polar vortex. Long-range models are suggesting a higher chance of a weaker than normal polar vortex this winter.
And a weak vortex means trouble. More cold outbreaks.
It means the potential for more cold air spilling south, exactly. Historically, La Niña winters already have a pretty high chance, something like 60–75%, of seeing a major midwinter stratospheric warming event.
That's when the vortex way up high gets disrupted.
Right. It weakens suddenly or even splits and allows that frigid Arctic air to plunge southwards.
So you combine a weak La Niña signal with a potentially weak polar vortex. It's like a recipe for some wild swings.
That's the key takeaway. High amplitude climate variability. Think sharp swings between mild spells and then these short but potentially severe Arctic outbreaks, especially for the central and eastern U.S.
Any historical examples?
Yeah, look back at the 2020-2021 La Niña winter. The La Niña forecast was right, but we had a sudden stratospheric warming event, and it brought that extreme, record-breaking cold deep into the southern plains. Texas, Oklahoma, totally opposite to the typical warm, dry La Niña signal for that region.
Wow. So high confidence in the variability, up and down?
Exactly. High confidence in the weather whiplash, but actually low confidence in predicting simple seasonal averages. They might not tell the whole story.
And quickly, any global impacts tied to this weak La Niña?
Yeah, a couple of things. It could mean an increased risk for an active late part of the 2025 Atlantic hurricane season because of reduced wind shear, and also higher odds of above average rain and flooding across parts of Australia and Southeast Asia.
Okay, let's shift gears now. Looking beyond this winter, you mentioned a potential major shift on the horizon for 2026.
Yes. There's growing evidence looking at longer range models and underlying ocean physics for a potentially significant phase reversal, a swing back towards El Nino, possibly starting mid to late 2026.
A major El Nino. What's the science behind that prediction?
It ties into something called the recharge oscillator theory of ENSO. The basic idea is that the Pacific needs to, recharge its heat content after an El Nino and discharge it during one.
Right.
A weak and brief La Nina, like the one forecast for this winter. It represents an incomplete oceanic discharge or an incomplete recharge of the cold water.
So it doesn't fully reset the system.
Exactly. It kind of leaves the Pacific Ocean preconditioned, almost spring-loaded, for a rapid and potentially powerful rebound back to a warm El Nino state once the La Nina's atmospheric drivers fade away.
So the very weakness of this potential La Nina actually makes a strong El Nino rebound more likely down the road.
It makes it physically consistent, yes.
It raises that possibility quite significantly.
Fascinating how interconnected these cycles are. So bringing this all back home, what does this mean for you listening right now?
Well, it means continuous monitoring is going to be absolutely crucial. We need to keep a close eye on those key indicators, the Niño 3.4 temperatures, that subsurface heat content we talked about, winds high up in the stratosphere affecting the vortex, the trade wind strength.
All those pieces of the puzzle.
All those pieces. They'll help refine the picture as we move forward.
So thinking strategically then, near term, it sounds like you need to prepare for that weather whiplash, high variability this winter.
Definitely brace for swings.
And longer term, start thinking about the potential impacts of a significant El Nino arriving in 2026. That has very different global consequences. Absolutely. This isn't just about forecasting the weather next week. It's about anticipating these larger climate shifts that can ripple through everything. Energy grids, agriculture, global supply chains, you name it.
Understanding these big patterns helps you anticipate what might be coming, allowing you to prepare, not just react. Something to definitely keep an eye on.